Hello, I am Rachana Marathe and I will be taking you through the Bressenhams circle drawing algorithm. This presentation is also available in SlideShare. This is the link for the SlideShare presentation. The aim of this video is to show some solved examples for circle drawing algorithm which may not be available in regular textbooks. This is the algorithm for circle drawing. This algorithm can be found in any standard computer graphics textbook. I have taken reference from Hearn and Baker. You can see the link to this textbook in the last slide of this presentation. Now let us go through the algorithm and solve an example to find the pixel positions on the circumference of a circle. First and foremost, it is important to understand that the two necessary things to draw or to find the pixel positions around the circumference of a circle are the radius and the midpoint. We always assume the midpoint to be 0, 0, but you should necessarily know the radius to calculate the pixel positions along the circumference of the circle. Another important point to note over here is we calculate only one octant values or xy coordinates of a circle. That is, if you have 4 quadrants, the first half of the first quadrant only we will calculate, because the other parts of the circle are just mirror images of this one arc that we calculate. Therefore, with these two information, that is midpoint being 0, 0 and the given or known item should be radius, and we will calculate only for the first half of the first quadrant, that is 1/8 of the circle coordinates or 1 octant of the circle coordinates. Let's look at the example. Here the radius, let us take it as 5. I have given the algorithm on the left hand side and the solution on the right hand side, so this becomes easy for you to compare with the algorithm as you go on with your calculations. The first point that we plot is always on the y axis. The first point that we are going to plot is always on the y axis of the first quadrant. So y axis always x will be 0 and the radius will be plotted on the y axis. So the first point to plot will be 0, radius. In this case 0, 5. Then because this is based on Bressenhams, we calculate the decision parameter. Here p0 equal to 1 minus r is the decision parameter, r is the radius. Therefore, decision parameter equal to 1 minus 5, which is equal to minus 4. Once we calculate the decision parameter, we have two options. If condition is true, we follow these. Else, if this condition is true, then we follow these, where x and y coordinates. If condition x is incremented by 1, y remains the same, and pk plus 1 is old pk value plus 2xk plus 1 plus 1. This is 2xk plus 1. If it is the else part, then x is incremented by 1, y is decremented by 1. It is decremented because the circle will come down like this in the first quadrant. So the y goes on decreasing. And the new pk is equal to pk plus 2xk plus 1 minus, that is the same thing, minus 2yk plus 1. Let us look at the first one. The decision parameter is minus 4, hence it is less than 0. Therefore, it will be the if case, and x k plus 1, y is constant. So x, y, which were 0, 5, now became 1, 5. And the new decision parameter equal to old decision parameter, minus 4 plus 2xk plus 1, that is 2 times xk plus 1. this 2 is 2 into 1 plus 1, which is equal to minus 1. Again minus 1 is less than 0, so again we are in the if condition. Xk plus 1, yk, so 2, 1 plus 1, 2, and 5 is constant or remains the same, and pk plus 1 equal to pk, the old pk value, that is minus 1 plus 2xk plus 1, 2 times 2, 4 plus 1, and the pk plus 1 or the new decision parameter is equal to 4. Now it has moved to the else part because 4 is greater than 0, pk greater than 0, that is why it will be in the else part. In the else part, xk plus 1, yk minus 1. So xk plus 1, 2 plus 1, 3, and y 5 minus 1. So it became 4, 3, 4. And the new pk value or the new decision parameter equal to old decision parameter 4 plus 2 times xk plus 1, 2 into 3, 6, plus 1 minus 2 times yk plus 1, 2 times 4, 8. The answer being 3. And this 3 is again greater than 0. Therefore, we are in the else case. When we come to else, x is k plus 1 and y is k minus 1. X is 3 plus 1, 4. Y is 4 minus 1, 3. We stop here because x is greater than y. Either we stop in this condition or when x equal to y. Because x equal to y or x greater than y would mean that we have moved to the second part of the first quadrant. Hence the pixel positions will be starting at 0, radius, moving up to where x greater than y or x equal to y, whichever the case depending on the radius, depending on the problem. So 0, 5, 1, 5, 2, 5, 3, 4 and 4, 3. And this is the link for the ebook for Hearn and Baker from where you can reference the algorithm.